SugarCrete is an innovation developed by the University of East London, which aims to upcycle sugarcane byproduct bagasse into sustainable construction materials. And sugarcane is the largest crop in the world, resulting in almost 600 million tons of bagasse per year. Sugarcane absorbs CO2 50 times faster than traditional forestry, which makes SugarCrete a very sustainable material, which can be carbon neutral and even carbon negative, depending on the location where it's produced. This means that it's a very sustainable alternative to high-intensive energy products such as brick, concrete, or steel. And depending on the application, can replace partially the use of traditional bricks, traditional concrete blocks.
The biggest attraction there was that bricks are a heavily energy-oriented product, which again leads to a lot of CO2 emission, because when the bricks are fired in the kilns, a lot of heat is used to bake them, and that comes from fossil fuel or any other fuel, leading to carbon dioxide emissions. Even more important from the long-term view for the country is bricks use topsoil, and the topsoil, if it gets moved out, then the crop output, especially for an agricultural country like India, would then again be hindered, and it is getting hindered. So that's why CST got interested.
SugarCrete has a strong social agenda, and the research developed so far is open source and available in the website of the university. Our idea is to partner locally and to bring the technology to as many people as possible within sugarcane plantations. Sugarcane factories, traditionally, depending on the region, but they don't work the whole year, so there is a period of the year where there is a lack of employment for families that are making their life out of sugarcane collection and processing. By bringing opportunities to use these byproducts and produce income and improve the conditions of workers living locally, we are hoping that we can first upcycle the material, and second, create opportunities for people working in local plantations.
If these blocks can be made close to the sugar mills, then not only it gives them additional income, but it also helps the local economy.
फर्स्ट टाइम हार्वेस्ट करेंगे लेबर वहीं पे, उसके पास अपने अपने कंसाइनमेंट है, किसी के पास बुल्क कार्ट है, किसी के पास ट्रैक्टर ट्रॉली है, उसके बाद वो लोड करेंगे, उसमें लोड करने के बाद फैक्ट्री ले जाएंगे एज पर रिक्वायरमेंट ऑफ फैक्ट्री। जितनी फैक्ट्री की रिक्वायरमेंट होती है वो हम सोसाइटी को दे देते हैं कि कल की रिक्वायरमेंट हमारी 1.25 लाख कुंटल गन्ने की है, तो 1.25 लाख का इंडेंट हम परसों के लिए दे देंगे उस सोसाइटी को। सोसाइटी 1.25 लाख की इंडेंट की पर्चियाँ किसानों को डाइवर्ट कर देगी, जिसके पास वो पर्ची का मैसेज पहुंचेगा वही किसान गन्ना लेके आएगा हमारे यहाँ।
The bagasse fibers that compose SugarCrete make the material very good for insulation. If we replace traditional bricks or concrete blocks with SugarCrete, we are achieving a very good thermal conductivity for the wall, which means that the thermal comfort internally will be better, and the energy that we will require to keep the building cold or warm, depending on the season, would be reduced significantly. The same fibers and the mineral binders that we are using to create SugarCrete also help regulate the internal humidity of the space. So the walls of SugarCrete are able to take part of this humidity from the environment to the wall, and then when the environment is drier internally, they can release back that humidity, helping us achieve a constant level internally.
I think keeping in my mind, actually this is the very sustainable model for the student and society, because the building material very low cost, and environment safety and human safety is the mandatory for our purpose of the life. So because is the material time taking, and the sustainability of the buildings and the requirement of the human is very impact for the society. We can understand how to together sustain the environment and human values and all the things we have mentioning for this concept. and sustainability to environment and ecosystem also. So this is the very beautiful concept.
So we wanted to translate all the lab work that has been done so far at the University of East London into practical output of the blocks, and then make a prototype or like a demo building where these blocks are used to make the walls and the building.
Being able to come here and actually see the building finished and be able to kind of hear the context in which the building is sitting for the education of the children in the future, I think has been really, really inspiring. Really, really pleased. And of course the building itself is, I've seen pictures of the development of this building, of the construction of it, but there's nothing that can beat actually visiting that building and seeing it finished. I mean, we're hoping that the students themselves get a brilliant experience of using the building, that they can, through the monitoring process and the kind of the exchange of knowledge that we can offer to them, will begin to understand what it means to engage in sustainable construction, in the use of data to be able to understand how it works, and that they can bring that together and find some inspiration for their future so that they can take forward the ideas as much as we can.